Hey internet friends, how's it going? So we're back here with the ProLinea 450 and I've got a 16-bit IDE controller to try. Now this one is jumpered for IRQ-15 and IO port 170, which is the default for the secondary IDE port in a system. So hopefully this won't conflict with the built-in IDE port. A lot of IDE chipsets actually implement two ports. So if there's something funny going on, there might be like this ghost port on 170 with no IRQ hooked up to it. That would be silly, but I mean, anything's possible. But so hopefully that'll work. If it doesn't, I can jumper it to something else that will. So that should be fine. And I've also got some RAM to try to install in this thing. Now, according to the book, the system supports a maximum of 128 megabytes, and it's got 4 megabytes soldered onto the board, and it also has a single 4 megabyte 70 nanosecond FPM RAM installed in the machine for a total of 8 megabytes. So what I've got to try in this machine are a couple of 64 megabyte FPM RAMs. Supposedly they're FPM RAMs, although the guy that I got them from also had them listed as being 60 nanosecond, which is generally an EDO RAM speed. So these may actually be EDO RAMs. I don't know. And I've never heard of 64 megabyte FPM RAMs. So, I mean, these could be for some old Unix workstation or something, but I've never heard of these being used in PCs before. But I don't really know much, so maybe I'm full of poo. I don't know. We'll try them. If they work, and it actually shows more than 128 megs of RAM, then I try to get another one of these SIMs somewhere. And since there are 3 slots, then we'll be able to get, more than 128 megs of RAM, which should allow us to run Slackware a little more comfortably. It doesn't really matter for DOS. I mean, we could stick with 8 megs for DOS, but I want to dual boot Slackware on this thing, and if we're going to run X11 a little bit, we probably need a little bit more RAM. I used to run X back in like the kernel 1.2.13 days. I remember that was the kernel that was shipping with Slackware at the time. I used to run Slackware on a 386 SX40 with 4 megabytes of RAM, and it would run X and TWM, but not very well, so I generally used it in console mode. But I know the software is probably all a little bit more bloated these days, but you would think that 128 megs running Slackware would be at least enough to use the console without X. But we'll have to see. Anyway, so if that doesn't work, I also have some 32 megabyte EDO RAMs. Now, 486s are generally meant for like 70 nanosecond FPM RAM, designed for. I think some of the later ones work with EDO RAM though, and this supports the DX4, so it may be a later board, so EDO RAM may work in this thing. I don't know. The manual doesn't say anything about it, but this particular configuration also isn't described in the book that I've got, which makes me think that this may be some like later revision of the machine. The riser's different and the motherboard is vaguely different and stuff, so I don't know what else to do other than try it. And I've got 4 of these. Well, I've only got room for 3 of them in here, but if this EDO RAM does work in the thing and the 64 meg SIMs do not, then we can at least get 100 megs of RAM in the thing, which, if these work, should still be good enough to get Slackware working passably. Yes, and speaking of which, If you're not running an ad blocker, you should do so, because YouTube is full of copyright scam bots, and even though the music that I use when I speed the video up is in the public domain, it was recorded in the 1920s and the copyright is expired on it. Due to the nature of public domain law, it's really easy for them to take advantage of YouTube's content matching algorithm and then run ads on these videos to make money. And all of my videos should be completely ad-free. Nothing is monetized by me here, so install an ad blocker and use it, because we don't want the copyright scammers to get any money. So cool. All right, let's see if we can make this thing work, shall we? This RAM test may take a while, but the RAM does appear to be working. Very good. But will it recognize them as 64 meg ZIMs, or will it only recognize them as 32 meg ZIMs? We shall find out in a moment. If it counts past 64 megabytes, because I've got both of them installed, then we will rock and roll. Yeah, boy. Oh, nope. It counted the 4 megs on board, so it's only seeing them as 32 meg ZIMs. That is unfortunate. Let me try the EDO RAM, and then we shall, if it works, then I'll keep the larger RAMs around for something else. Here we've got the EDO RAM installed, so let's see if the machine likes it. I guess the most we can do here is 100 megs of RAM in this machine, though. Okay, so well, it appears to be, the EDO RAM appears to be working in this board. Now, I've had 486s in the distant past that would use EDO RAM, but they were unstable with it. So if the system starts displaying instability, then we'll have to use some other kind of RAM. But that does appear to be working, and I guess 100 megs, or well, it'll be 104, yeah, no, it'll be 100 megs of RAM, because it's got 4 soldered on board here and 3 32 meg ZIMs here. But there, it does appear to be a place to solder in another RAM socket, so it may be possible to desolder this RAM that's on the board and install a socket, or even solder different RAM onto the board, larger RAM. So I may look into that. I mean, there's not a huge difference between 100 megs and 128 megs anyway, so I'm not going to go to too much trouble if Slackware runs alright on 100 megs. So yeah, it found 100 megs, so that's what we're doing then. I guess that's how we'll run the machine until we see if it's unstable or not. So let's test that IDE controller now, shall we? Okay, so we're back on the original 240 meg counter drive that came in the machine, hooked to the internal interface, because this drive has the XT-IDE BIOS and the flashing tools on it. And I've got the expansion card installed. So what we want to do, I think, is we'll have to re-enable the BIOS or the boot ROM on the network card, and then flash the new BIOS onto it. And we'll set the expansion card as the primary IDE interface at 170, and then we'll set the internal IDE interface, the built-in IDE interface, to the secondary interface on 1F0. Let's try this and see if we can get it to work. And then once we get the BIOS flash and everything, then we'll plug the LBA disk back into this interface and make sure everything's cool. Let me see here. IRQ-12 should be free, right? Yeah, because 14 is the default for the primary IDE interface, and 15 is the default for the secondary IDE interface. But we're going to have to reverse those. So, okay, so the ROM address was at D000, right? 340 and IRQ-12. Okay, but we have to change the IRQ back because it changes it for some reason. Okay, 340, IRQ-12, twisted pair, PIO mode, and the ROM is enabled. Okay, so now okay, so we'll load our, we want the 8K 386 BIOS, yeah, okay, then we need to configure it. Okay, primary IDE controller is a 16-bit device at 170, oh, 170, oh shit, that ought to be 370, I think, right? Yeah, pretty sure. Yeah. Okay. The interrupt is enabled and it is on IRQ-15. Right. The secondary IDE controller is 16-bit at 1F0. And the control block address should be 3F0, right? Yeah. Interrupt is enabled and it'll be on IRQ-14, presumably. Assuming this thing uses the default IRQ. Okay. Boot settings. Okay. How to detect floppy drives. We don't need to enable that. Yeah, okay, that shouldn't matter. Just keep power management disabled. Okay. Now we'll flash the ROM, and hopefully we're not supposed to power cycle the machine before we do this after reconfiguring the network card. I guess we'll find out. It is a 2864, yeah. Okay. Just keep the defaults there. Yeah, I'll have to restart the machine, I guess. I hope it doesn't. I hope it boots right. No, I'll reconfigure it later. All right, let me power cycle this, and we'll try again. All right, I put the configuration back how we wanted it. So let's go ahead and try to flash the ROM again. Yeah, that all looks right. Okay. So that's it. Alright, I gotta hook up the other drive. I'll be right back. Alright, both drives hooked up. It should boot off of this one, and then hopefully we'll be able to read copy all the stuff off of this drive onto that one. Then we'll have the XTIDE configuration utility and the network configuration utility and stuff already on the FreeDOS disk there, and we won't have to mess around anymore. So let's see what happens. I will interrupt the RAM test early so we don't have to sit through all that. And of course, since the original drive is still hooked to the internal controller, it's going to complain because it's disabled in the built-in BIOS. So we'll have to ignore those changes for the moment. So it'll go ahead and boot. Oh my! That's some weird stuff right there. I don't know what the deal is with that. No, that's not working at all. Let's unplug some stuff. Alright, so I unplugged everything from the, what? Disk 3 type 2? Disk 3 type should be 0. Oh, jeez. Is it... I get... Oh! The BIOS! The BIOS is supporting a secondary IDE interface on the standard secondary IDE interface I/O port and IRQ. Well, I/O port anyway. We're gonna have to change that to a different I/O port then to make this work. But let's hit F2 again and just see if. Okay, it identified the drive right that time. That was very strange. Yeah, let me, okay, so I'm going to, yeah, let me reconfigure the I/O port on this card, and I'll have to reflash the BIOS again, and then we'll see what's going on. Okay, so now now this card is jumpered to like 1E8 or something like that. I don't remember. Well, the BIOS will tell us. And I reflashed the BIOS, and I've got the old Connor drive hooked up as a slave drive now, and everything's plugged into that expansion card. So let's see if it works this time. Surely the built-in BIOS won't try to probe on that weirdo non-standard port. Alright, yep, it found both of them. Good. 1E8, yeah. Alright, it's booting FreeDOS. It sees both drives. We can read everything on drive D. Oh, we don't even have a DOS directory. Did I forget to... Yeah. Okay, I'll have to get FreeDOS installed right. I guess for now we can use DOS 6's xcopy command, right? It ought to run under FreeDOS. Oh boy now. Okay, well, I'll fix this later. For now, let's continue this project. I'll just have to finish installing FreeDOS on this machine. We'll do that after a while. Alright, so to summarize what we have done so far since the beginning of this project, in case you have not watched previous videos, we cleaned the machine up. We decided we wanted to install a 40 gigabyte hard drive in the thing so that we could comfortably dual boot both DOS and Linux. We installed an XT IDE BIOS on a network card. This is an NE2000 card. We modified the network card so that we could flash the ROM in system because these cards, unless you rearrange some stuff, don't support these electrically erasable PROMs. We have a Sound Blaster 16 installed. This is the Vibra 16, the CT4170. I think it's an ISA PNP card. I haven't even tried to configure it yet, but we'll figure out what we're doing with that later. And in order to make the large disk drive work, we have to, that's why we installed the XT IDE BIOS, but the built-in BIOS bitches about having its disk drives disabled because we don't want it to detect the disk drives, we want the XT IDE BIOS to detect the disk drives, and if they both have the disk drive set, the machine won't boot. So, in order to get around that problem, we obtained this snazzy little single IDE port card from a kind fellow on the Vintage Computer Federation forums. it's exactly what we needed, and it will fit with the next thing that we're going to do. So, this machine has 3 ISA slots. We've got 3 cards here that need to be installed, but I need to have a free slot so that I can install the expansion card that I'm going to build, that I'll be needing to develop drivers for on this thing. So, what are we going to do? We've got to get rid of a card, but how are we going to play Dune without music? No, I don't think so. Let's see what's going on with this riser here, shall we? Should have taken this out before I started recording again. Now you're going to get bored watching me mess around, aren't you? You're probably already bored, so maybe it doesn't matter. Oh, come out of there, screw. Don't be a pain. Now, let's see. I guess we can pull this whole thing out now, right? Yeah. All right. Now, here is our ISA riser backplane card. And on the back of it here, well, let me take it off of this bracket so you can see it better. Things are in the way here. Oh, come out, screw. Don't be a jerk. That's my job. Okay. Alright, now we've got the riser off. So you can see we've got 3 slots on this side. But you can see down in there, there's a place for another slot to be soldered in. Well, what's the use of having a slot like in between these? Nothing will fit. Well, if we look at the back, that's where the silk screen is. It looks like there's a place for another ISA slot on the back of this card. There just isn't one soldered in. And I toned this out with my multimeter, and indeed, the pads are reversed. So the slot is meant to be soldered in on this side. So if we do that, and we take the bracket off of this card, which is riveted in there, so we'll have to drill the bracket, we'll have to drill the rivets out before we can take the bracket off, and solder in a 16-bit ISA edge connector here. We ought to just be able to install this IDE controller right in here like this, since it doesn't need any external ports or anything. We ought to just be able to have it sitting inside of the machine here like this once we get this bracket off. And then we'll have a free ISA slot to do our fun stuff with. So I'll have to clean up here a little bit, and we'll have to find an edge connector, which I have over here. I've got a couple of these old backplanes for industrial computers, and this one's got all kinds of slots in it. I will never need to use all 5 of these 16-bit ISA slots on this card, if I ever use it for anything. So I'm just going to go ahead and desolder one of these edge connectors. Hopefully we can get it off of there without damaging it, and then I will solder it into this riser. We'll have to suck the solder out of all these holes. So let me clean up here a little bit so we have room to work, and we'll attempt this task. Yes. for my alcohol cleaned up the flux with to dry here before I reinstall it in the machine. But the connector's on there. It was very difficult to get down in here and solder without bumping the edges of these connectors here and kind of melting the sides a little bit, but it's not bad. It's just cosmetic. It won't hurt the function of the machine any. So I had a heck of a time getting that pin that goes into the ground plane desoldered. I ended up having to turn the desoldering gun up to like 475 degrees to get enough heat to go through both sides, and I think I may have burned the plating out of the hole. So the ground plane is ganged together in some other places here though, so that shouldn't matter, I don't think. So yeah, shouldn't be any problem there. Let's see, I guess the next thing is to get that bracket off of that ISA card. Yeah. Apparently I forgot to press record when I drilled these rivets out of this bracket. Obviously we don't drill down through the entire card, we just drill far enough to take one side of the rivet off of and then wiggle, wiggle, wiggle until the thing comes off of there. I did get down into the board just a hair, but not enough to matter. It'll be fine. Alright, let's see here. ISA interface goes in here. Yeah. Whew. That is a tight connector. I guess that's good since it's going to be unsupported. And the ISA cable goes, pin 1, goes on this side. Plug that in first before we put it back in here and forget what goes where. And we can, that's a floppy drive cable, that's got to stay. We can get this secondary floppy cable down here out of the way. You can go down in here underneath of those power cables if you want to. That's pretty good. And this will go in right here, like that. Yeah, it's a tight fit, but it fits very good. Now, let's put our bracket back on. Alright, now I guess we probably ought to test this thing before we go any further, huh? That would probably be a good idea. Oh, I'm a dummy. We have to have our network card in here if we expect to boot, because it's got our new BIOS on. Let's get that in there. Put it on the bottom this time since it's bigger and doesn't have any connectors on it. Now let's see what happens. Alright, it's booting. That's good. I've got this thing booted off of a floppy, and I've dug up this parallel ATA DVD-RW and plugged it into this thing, and I also dug out a SATA DVD-RW and hooked it to the machine downstairs because I haven't had an optical drive in anything for years. But it doesn't appear that there is any other way to install FreeDOS easily than having an optical drive. So I burned it to a DVD-ROM. Although it would fit on a CD, I just didn't have any CDRs, just DVD-Rs, and it seems to be working alright. The installer running off of the floppy drive is very, very slow. But FreeDOS is pretty cool once you get it running. If you tried it years ago and it sucked for you, well, try it again because it's improved a lot. Anyway, yeah, I was gonna just record all of this and put music to it, but it's taking so long. I'm just gonna go get something to eat, and you don't want to sit through all this even sped up with music. So, I'll be back after a while. Bye! Alright, FreeDOS installation complete. And here we are. That's actually pretty good memory usage. I was expecting FreeDOS to use more than that. I guess it's loading just about everything into UMBs, and I've heard that FreeDOS's XMS manager is far better than DOS 6's as well. So, pretty cool. We have a CD-ROM driver in FreeDOS, so we can list the contents of this Slackware DVD here. I wonder where the boot floppies are. No. Ah, there we go. That's what we're looking for. So let's so this is a boot floppy that lets you then boot off of the CD. That's the whole reason we had to boot off of the floppy to install FreeDOS. This machine, even with the XT-IDE BIOS, won't boot off of a TAPI device. So that was a very small floppy disk. Well, let's boot it and see what happens. Save the changes? No, don't save the changes. Okay. There we go. I farted around here a little bit with different versions of Slackware. Should have read the documentation a little closer, I guess, because looks like with 100 megabytes of RAM, Slackware 12.2 is the latest version that will run well on this machine. That's a 2.6 kernel. It does use Xorg rather than x86, and it uses UDEV and a lot of the stuff that we're familiar with in more recent distributions. So that should be fine. And I have to say, I had forgotten how much I enjoyed Slackware back in the day. Alright, we've got Slackware 12.2. It's about 12 years old, but I think it's the latest version that'll run on this thing. So let's Slackware is like using an old Linux. Reminds me of how much like Linux used to be. And it makes me kind of sad that more modern Linuxes aren't really so Unixy anymore. Because I like Unix a lot. Anyway, alright, so I've got that original 420 meg drive that came out of this machine hooked up as a slave, an IDE slave now, so it's going to be on SCSI drive B, even though it's an IDE drive, it's still calling it SD instead of HD like they used to. So let's look at the partition table. Okay, It's actually partition number 3, but it's at the beginning of the disk. That's very strange. But it says it's a ID 12 Compaq Diagnostics. I think what I'm going to do is SDB3, right? Yeah, okay. I'm going to make an image of SDB3. I hate this keyboard. Okay. Probably should have run that in verbose mode. It's not a very big partition though, is it? It's only, yeah, okay, we're done already. And now, I'm going to assume that this so-called Compaq Diagnostics partition, when you go into the setup, when you go into the BIOS setup, it actually says starting MS-DOS. So I'm going to make an assumption that that is actually a FAT16 partition. Just has a different ID number. So that being the case, we should be able to mount this image that we just made on the loopback device and see the files. Let's see what happens. Mount -o loop -t MS-DOS on MT. Okay, let us mount it. Let's see what's looky there. All right. All right. Hot diggity. I want to make a copy of all of this stuff in a place that I can get to it. Let's see. I'll just copy it to the DOS partition. I'll just call it setup, and then we will. Let's, it's really late. I've got to go to bed. Things seem to be working fine. It takes forever to boot. I'll show you the boot sequence sometime when I don't need to go to bed. But that's alright. It also may have taken, this is the first time it's been booted too, so it had to generate like SSH keys and shit like that. So it probably won't be near as slow next time, but it still boots pretty slow. It boots DOS real fast, but it boots Linux pretty slow. Also, there was one other thing, but it's super late and I'm tired and I can't remember what it was. I don't remember. We'll finish this tomorrow evening. Yeah, okay, cool. See ya tomorrow. Yeah.